and post it on the Edmodo. It's on my YouTube channel. So you're going to take this home. I'm going to put 100 in the grade book for every one of you. Okay? You're going to keep it. You're going to take it home. You get a chance later this week. Look over the ones that you didn't finish, or finish them and then look over the review to see if you did them correctly. You should, by the time you're done, we should have probably 17 of the 20 already done, maybe even more. Okay, so please take time to look through it. This is how the class is going to work for the next 2 school weeks. Similar to this pretty much every single day. We might take a little quiz one day, modified in there. Don't try and lean in to get in the video. Lipstick. All right. We're going to go over 13 first. Please follow along. Please, when I ask questions, answer. Dave, or Dawn, sorry. Dawn keeps track of her. Are we done? Dawn keeps track of her softball batting average each year. The first year, her batting average is 783 thousandths. So the first year is 783 thousandths. Notice as I'm going through these word problems, I'm writing down things, or I'm going to circle it if I have the words in the paper right in front of me. However you're going to do it, that's fine, but make sure you show your work. You write down what's important. What we talked about a little bit in the past is some of you guys aren't even looking in your journal, you're not showing any work, you're wanting to do it all in your head. That's not helpful. Then it says her second year. Her second year, her batting average is 81 hundredths. In which year did she have a greater batting average? Comparing decimals. Hunter, what do?
We compare the tenths.
Okay. And what I'm going to do to make it easier to compare them is line up the decimal points. I'm going to put my magic 0 in there. Then once I've lined up the decimal points, put in my magic 0, I can compare place value to place value. Okay, or I can just read it 783, 810. Okay, so the answer is the second year. Your answer is not 81 hundredths, because the question asks in which year. You need to make sure you're answering the question they ask, not what question you want them to ask or what question you think they're going to ask. The actual question that they ask. That's going to save you a lot of grief when Mr. McMurdo grades papers. He can be a jerk, I've heard. So now if you were to do a stupid test at the end of this month, that's how you compare decimals. Piece of cake. Line them up, magic zeros, and go. All right, the next question. We have a table, mountains over 3 miles high. The mountains and location: Blackburn, Alaska, 3.104. Bona, Alaska, 3.134. Steele, Yukon, 3.152. Use math language. How does the height of Steele Mountain compare to the height of Blackburn Mountain? Compare the heights using words. So I'm doing Steele Mountain and Blackburn Mountain. Okay, so what is the height of Steele Mountain, Addie?
3.152.
And the height of Blackburn Mountain, Malia?
3.104.
This was 3.152?
Yeah.
Is that right? Okay. Okay, so then if I asked you in words, Kason, in words, like the problem says, compare these using words. Which one's taller?
The Steele Mountain is greater than the Blackburn Mountain.
What do you mean greater than? Taller. We don't say, hey, that mountain's greater than that mountain. That doesn't tell us what it means. Steel Mountain is taller. If I asked you, Elena, how much taller, how would you figure that out?
You can compare first to see which one's greater than the first row.
Okay, I already know that Steel Mountain's taller. But how would I know how much taller? How would I figure that out? It doesn't tell us here, but it gives us the information to figure it out. How do you figure out, okay, Caden is 4 feet tall. I'm 6 feet tall.
Okay, I'm 5.
How would I tell how much taller I am than him?
1 foot.
4 feet, 6 feet.
2 feet.
How did you figure that out?
Because I subtracted.
Because you subtracted. Okay, so that's how we're going to do this. Remember, subtracting decimals. Subtracting decimals, you line up the decimal points, add magic zeros if necessary.
Magic's here.
So if I were to ask how much taller, it'd be 48 thousandths miles taller. Is that more than or less than a half a mile?
Less.
Less. A half a mile would be a 0.5 right here.
0.5.
Stop intentionally doing that.
I'm not.
He is.
No, I is not. Yeah, you is too.
Can I go to the bathroom?
It is not.
Now the next one. What if the height of Blackburn Mountain were 5/100 miles greater? Would it then be the mountain with the greatest height? Explain. So right now, how high is Blackburn Mountain?
3.104.
Okay. So right now, go Hunter. Right now, this is how tall Blackburn Mountain is. The question says, what if it were 5/100 of a mile taller? How are you talking? What if it were 5/100 of a mile taller? Okay, so we're gonna just add it. Adding decimals, we line up the decimal points, magic zeros. Okay, then the question says, would it then be the mountain with the greatest height? So if Blackburn Mountain was, how do you say this, Mueller? How do you say this number?
3 and 154,000.
Good. 3 and 154 thousandths. Would that make Blackburn Mountain the tallest?
Yes.
Yes. Okay, explain in words, or what the direction said. Okay, explain in words. Colin, how did you explain it in words?
What number is this again?
I don't know.
15.
33.
I said yes, cause, and then I did the equation. Like,
Okay, now listen. If you were doing a stupid test at the end of the month that is very easy, not very difficult, and all of you should do very, very well on, if that happened, you've compared decimals already. We've done a review. And now we've also done a review of adding and subtracting decimals. Okay, that's going to be worth points when you're doing that stupid test. That should help you. Every day you should gain some more points for review. I don't want to know. If you have to potty. I'm not going to sit here and babysit you. Because you don't have to go. You just want to hear yourself. Let's look at the next one. The next one, we have a chart with insect speeds. We have dragonflies, horseflies, bumblebees, honeybees, houseflies. The speed of which two insects, when rounded to the nearest whole number, are the same. Okay? So if we have, and I'm going to write them all down just so we can show, we're now learning to round. So we've done comparing, adding and subtracting. Now we're doing rounding decimals. So if I said the dragonfly, read this, I'm blind. What's the dragonfly's speed?
6.974.
What's next?
Horse,
3.39.
no.
3.934.
3.934.
3.934.
What's next?
Bumblebee 2.861.
And then the honeybee is
2.548.
2.548.
And then there's the housefly 1.967.
1.967.
Okay, housefly.
1.967.
One.
I just had to look.
Yeah, you got them all.
I didn't have
All right, so this is what the chart looks like. I've noticed based on past experience, I like to do lots of charts and tables on the on that silly test that you may have to take at the end of the month. So a lot of the review, I'm going to try and throw in as many charts and tables as I possibly can. Okay, so now the question asks, if we rounded them to the nearest whole number, the nearest whole number is the ones place. So if we rounded these to the ones place, which two would round to the same? So they'd have the same numbers in one place. Now let's think. Put your hands down for a moment. Let's think. I know in your journal you had your rounding song. Some of you liked, some of you didn't. I don't care. Use it, don't use it.
You round your
Okay. Find your number. Look next door. 5 or greater? Yes. Add one more. The numbers in front stay the same. The numbers behind, 0 is your name. Okay? So 6 and 974 thousandths is going to round to 7. This one, the horsefly, is going to round to what?
4.
The bumblebee is going to round to what?
3.
The honeybee is going to round to what? And the housefly.
2.
Okay, so what is the answer to my question?
The bumblebee and honeybee are the same.
Good. The bumblebee and the honeybee round to the same if you round them to the ones place. Again, show work. Work through the problems. Take your time. Use your brain. And nothing that you're going to do is beyond your abilities. Most of you have worked hard this year, except for Mueller. So most of you are prepared. Well, I'm hoping the next 9 days will get you prepared, Mueller, since you've taken the rest of the year off so far.
What?
What is the speed of the housefly rounded to the nearest hundredth? Okay, so the housefly. What was the speed of the housefly on the chart say?
1.967.
Are you gonna tell me?
And it asks you to round to what place value, Gabby?
100.
Hundredths. What number's in my hundredths place, Gabby?
What?
No, that's my ones place.
Oh,
6.
Okay. Now that's a good idea, Hunter. What? Okay. You have 4 hours working on this test. Your brain's going to get tired. One of my suggestions for you is to make a place value chart. When your homeroom teacher says, hey, you may begin, there are blank pieces of paper all over that test booklet. Draw a place value chart. Just to keep, all you have to do is go out 3 behind the decimal point. It's going to make it, when you're working on the problems later, you're an hour and a half in, your brain is tired, you can go back to your place value chart, and that's going to help you remember things. Okay, you don't have to remember everything. You have a formula chart in there. Write down a place value chart. Write down a multiplication chart. Perhaps the G. I find the G helpful. So there are several things that might be helpful. Maybe that King Henry thing that we do, that might be helpful. Okay, so now it wants to know what the housefly is, rounded to the nearest hundredth. Gabby, we found our number. We look next door. Is the number 5 or greater?
Yes.
Then we add one more. So that's a 7, 9, 1. Numbers in front stay the same. Numbers behind, 0 is your name. You'll probably be seeing it written, if it were a multiple choice, you'd probably be seeing it written without the 0 at the back. But, because you know, if you put a 0 at the back, that's a 0 in the thousands place. It doesn't matter. Okay, go around that way. Okay, it doesn't matter. So it's not going to change anything. That's like your magic 0 when you're comparing. If you have one at the very back behind a decimal point, it's not going to change the value.
Oh my goodness.
Let's see. A rounded number for the speed of an insect is 5 and 6,700 meters per second. So a number, we got the speed of an insect, and if we rounded it to the nearest hundredth, that's what it's going to round to. Now it wants to know, what are the fastest and slowest speeds, the thousandths that could round to 5 and 67 thousandths? Well, to round to 5 and 67 thousandths, let's list all the speeds. Let's see, 5, 6, 7, 0. 5, 6, 7, 1. 5, 6, 7, 2. 5, 6, 7, 3. 5, 6, 7, 4. 5, 6, 7, 5. 5, 6, 7, 6. 5, 6, 7, 7. 5, 6, 7, 8. 5, 6, 7, 9. These are all the ones that have a 5.67 something. And we want to be able to round to 5.67 something. Is there anything else I could round to 5.67 something? I can round 5.66s, right? Okay? So if I went through, and I'm not going to do it all because I already know the answer. If I made it 5.676, right? Or let's see, 5.6. No, I don't want 6, 7. I want 6, 6. 6, 6, 6, 0. I can see what the smallest one is. I want to know which one's the biggest that would round to this, and which one's the smallest that would round to this. Okay? So if I did 5.670, is that going to round to 5.67?
Yes.
Yes. This would round to 5.67. I don't think that's my answer. There's probably some numbers that are bigger that will round to 5.67. What about this one? Is that going to round to 5.67?
Yes.
Yes. Again, find my number, look next door. If that's not 5 or greater, I don't add one more. Is this going to round to 5.67? Yes. Is this one?
Yes.
Yep, pretty.
Is this one?
Yes.
Is this one?
No.
No. This one's going to round to 5.67 or 5.68. So the biggest one that will round to 5.67 is 5.674. Yes, sir. Sure. The smallest one that would round to 5.67 is going to be 5.666.
Wait, what at 5.665?
Oh, you're right. Good. 5.665. Thank you. That would be the smallest one that would round to 5.67. Again, I wrote down a lot of stuff. I showed a lot of work. This should be kind of giving you some thoughts on what maybe your paper should look like as you're going through an assignment, as you're going through an exam, as you're going through life. Life takes work.
No pain, no gain.
That's what I've heard. But then every time I kick a student in the shin, I don't gain anything. I just get in trouble.
You get in trouble? How many students have you?
All right, the next one. The men's 500-meter speed skating final. Evaluate. Apollo Ono won the men's 500-meter speed skating final at the 2006 Winter Olympics. Are we going to continue talking?
No.
I would rather you didn't. Oh, his time for the race was 41 and 935 seconds. So Apollo Ono was 41 and 935 seconds. Are we going to keep saying that because it wasn't funny the first 9 times you guys said that?
Oh no.
No more.
Oh no.
Francois Louis Tremblay. So I'm just going to put FLT. Came in second. He was 67 thousandths behind Ono. What was Tremblay's time? Now, let me ask you a question. Because this will be something that tricks you. This will be something that tricks you. If you're in a race, Jasmine, do you want the lowest time or the highest time? The lowest time. So if FLT came in second behind AO, his number is going to be higher. So if we have 41 and 935 seconds for AO, FLT needs to be a bigger number. And when we add and subtract decimals, line up the decimal points. I'm gonna guess that there were some of you that subtracted, but when you're thinking of a race, you always have to slow yourself down and think of a race as you want the shortest time, the fastest time. If it's a race. That's a 15, so we got 8, 6, 8, 1, 4 decimal point straight down. So FLT's time would be 41 and 868 thousandth seconds. I guarantee you, if this were on a test I gave, or a test somebody else gave, they would have the answer that you subtracted, and they would put that answer there, and that would probably get about 50% of you.
Wait, didn't you just subtract?
No, I added. Oh, I did subtract, didn't I?
Yeah, you subtracted.
Well, thank you.
That was the right answer.
What the?
That is the wrong answer.
Wait. Oh, that was the wrong answer. They're wrong.
And then,
I was gonna say.
Okay, my bad. So his actual time for FLT would be 42 and 2,000 seconds. I see. I wrote the addition, still did subtraction. Okay. So again, I make mistakes, and I'm not thinking clearly at all times. Okay. But it's going to catch about half of you if you don't slow your thought process down. All right, let's look at the next one. Shh. Stop talking, please. The next one says, John Eli came in 5th in the men's speed skating final. How many seconds after Apollo Ono did Eli finish? Okay, he came in 5th in the men's speed skating final. How many seconds after Apollo Ono? We know Apollo Ono was 41 and 935 seconds. John Ely, and again, refer back to your chart every single time. Show your work every single time. John Ely was 42 and 497 thousandths seconds. So what am I going to do to find the difference? How much more? Stephen.
Subtract.
Subtract it like it's written, like Ness?
no.
No. I got to put Ely's times a bigger number, so I got to put Ely's time on top.
Yes.
Now if I subtract, 7 minus 5 is 2. 3, that's a 7. 10, 12, 13, 4. So it's 472 thousandth seconds. Please stay on task, paying attention. Try and learn something.
Is it 9 minus 36?
Is it 9 minus 36?
Okay, then that's what it is.
Okay.
Stop yelling at me. I am messing up. It's been a long day already. My bad. All right, so again, what I'm going, yes.
Shouldn't the 10 place get 5?
Yeah, because you forgot to change it. 5.
7 minus 5 is 2. 9 minus 3 is 6. I had to borrow.
14 minus 5.
So that is 14 minus. Goodness sakes. So
So
that
that is
should be
5.
5.
Okay, I got that right.
Goodness sakes, my brain's turned off. Okay, so it should be 562,000 seconds. 562,000 seconds.
Really, Jason?
Really, bro.
All right, going on to the next one. Please stay with me. Follow along. By the time we're done on the Edmodo, you should have posted for pretty much everybody, almost every problem. All you're going to have to do is go there or go to my YouTube channel to find them. Let's see. Tony has a ribbon that is 2 7/500 meters long. Okay, again, important information. If I had this paper, I'd probably circle it. I don't, so I'm writing notes down. Let's see. She cuts off 345 thousandths meters. How much does she have left? So she cuts off 345 thousandths meters. Okay, we want to know how much she has left. Caleb, if I have this long and I cut off this long, I want to know what this part is. What am I doing? What operation? Subtraction. When I'm subtracting and I have decimal points, I line up the decimal points. I have to add my magic 0. If you don't add a magic 0, you're going to get this problem wrong. Okay, because I can't do nothing minus 5, and what many of you are going to want to just bring down that 5, which there is a 5 in the thousandths place, but that'll change this since I have to borrow from the hundredths place. 10 minus 5 is 5, 4 minus 4 is 0, 7 minus 3 is 4, 2 minus nothing is 2. So if I did my math right for the first time in 3 problems, you should get 2 405 thousandths meters
That's
left.
right. Your brain turned on, Mr. McMurdo.
Thank you. It's been on.
It's not going cuckoo.
Well, it probably will be.
Forgot a subtraction.
At least for that problem, it didn't.
Forgot a subtraction symbol.
All right. Following along. I got off task and this. I need stops. Doesn't matter. You guys are picking it up at the end of the day anyway. Dara spends $13.02 on sandals. Yes. $9.85 on shorts. $15.20 on a hat. Okay. Sit down. Don't get up. Sit down. Don't get up. I don't care. Let's see. How much change does she receive back from a 50? So she pays with a $50 bill. Okay? So I need to know how much change she gets back. Molly. Okay? How do you want to solve this problem, Molly? You're brilliant. I know. Tell me how.
You want to.
Oh, that would be difficult to do in your head. But that's just me. Reagan?
Okay. You add what you spent on the sandals, the shorts, and the hat, and then you subtract it from 50.
Excellent. It's just like you're going to the store. The guy's going to go, $13.02 for sandals, $9.85 for shorts, $15.20 for a hat. Then you're going to have the total.
Simple grocery store shopping.
Again, when we are adding and subtracting decimals, line up the decimal points.
I have important news.
Yes.
I'm gonna have a baby sister this week.
Awesome. So now, Molly.
On camera.
Molly, after they went to the grocery store, after they went to the store, Dimitri, I need you with me, please, paying attention. After they went to the store, said, your total is $38.07. And you're like, I'm rich, man. Boom! And you slam a $50 bill on the counter. How would you figure out how much change you're going to get, Molly?
Oh, I know what trick. Can I tell you?
No. So, if I did my math correct, you should get $11.93 back.
Yes.
$11.93 back.
You did it. Get your foot off my desk.
Okay, love, I need to quiet.
Okay. It's not on your desk.
Okay, well then fine.
They're not on
Okay
your
then.
desk.
Okay, you guys get the inside of the desk cleaning.
Yeah.
Alright, let's look at one more before we stop. Jimmy adds 3 and 2400ths, 4 and 294 thousandths, and 2 and 73 thousandths. How much more than 5 and 31 hundredths is the sum? Okay, we have to do two things here. We have to add the numbers that Jimmy adds together, adding with decimals. Now some of you are playing, and I could just take this for a grade instead of going over it and put your grade in the grade book, and I guarantee it's not going to be 100. So my suggestion is to you is to follow along. Okay, put in my magic 0, 7, 16, 17, 20, 2, 4, 6, 3, 7, 8, 9. Okay, so I got 9 and 607 thousandths. When I added that together, the question asks, how much greater is this sum than 5 and 31 hundredths? Notice 9 and 607 thousandths is an answer choice. They're not dumb. They know what you're going to pick. If you're lazy and you just do that and you don't finish all the math, you're going to go, oh, there it is, instead of reading through the problem, because that's not the answer. Should be 4 and 297 thousandths.
Yeah.
See, I'm
Okay,
smart. And I'm
so the back side, the side we just went through, please stay with me. The side we just went through, rounding, comparing, adding and subtracting decimals. The other side, which you'll have access to watch that video too, talks about multiplying, dividing decimals, some adding and some subtracting. Okay. If you watch both videos, actually you only have to watch the one you didn't see, you're going to know how to do everything you need to know to do in decimals. That means there's not a reason for you to get any decimal problems done incorrectly. You know how to get every decimal problem done correctly. As you saw with me working, you may see mistakes. But you'll already know how to do them all correctly. Okay, questions? I'll have it posted on the Edmodo before you get home today.
I had a